So that's going.
All right, we'll kick back off again now, guys. We're starting again, guys.
Be good if I turn the microphone on. Hello, hello, hello. Yep, that's working. Alright, I think we might get started now. Alright, so how was pizza? Was it good? Did everyone have enough? Because apparently we ended up with twice as much as what we ordered. So if there's any still out there when you leave, take it. I don't know about Thailand, but cold pizza is a very Australian breakfast dish. You know, there's always a little bit of pizza left over. You get up the next morning, you go to the refrigerator, and there it is in the box, and just go, yep, I don't need to cook anything else. That will do fine. Cold pizza. All right, cool. So let's move on a little bit now. We're actually powering through this a little bit quicker than I thought we would. So please don't be afraid to ask any questions or anything like that, because I still have to keep you entertained for about 30 more minutes. But probably what I wanted to have a look at now is, does everyone remember that when I went in to change the code, it wouldn't let me commit directly to the master branch? I had to go and actually create a branch, and then I could make my changes, and then we go through the pull request process. And we've brought in a lot of tools recently to allow you to be able to enforce particular requirements upon your developers. And that's all managed in the area. If you're an administrator of your repository, you get access to this little tab called settings. And in there's a little section called branches. And in branches, we've got this little area called protected branches. And you can see that already sitting underneath here is the master branch. And if I had other branches, I could actually protect those and implement different kind of policies as to how code can actually be committed to that particular branch. But I've only got one at the moment, the master branch. And sitting in there, if I click on the edit button, we can actually look and see how I set that up to make sure that developers can't push directly to the master branch. That required a pull request review, in other words, a code review before it was permitted to be able to merge, and that they actually had to approve it, not just go okay and have it as a comment or request changes. It actually had to be approved before we could merge the code into the master branch. There's a little interesting button down here that I didn't really demonstrate, a little interesting checkbox that I didn't demonstrate that says dismiss stale pull request approvals when new commits are pushed. Can you imagine what it would be like if, for example, somebody had a pull request, they made some changes, you did an approval, you approved it, and then it would be ready for merge. But in the meantime, that person can come in and make additional changes. Well, you haven't really approved it, have you, at that point? So what you can do is by ticking the box here that says dismiss stale pull request approvals, if I've actually approved your code and then you go ahead and change it, it forces me to approve it again before we push it into the master branch. Now some people may ask, well, why is that just not a default thing? The more boxes that you tick on this page, the more secure your code will be, but the longer it'll take to get your code out there, because there are so many more things that have to happen before you actually get your code out there. So it's always a fine balance between how secure you want your code versus how quickly you want to get your changes out into play. So for example, we've protected the master branch, and by protecting the master branch, this means that we can't force push. In other words, force pushing allows you to rewrite history. Again, you may be working for an organization where you're not allowed to rewrite history. Rewrite history actually works in certain cases to do with some historical things around Git. But if you're working in a banking industry, for example, then you don't want to forcibly overwrite the history of changes to your code because you're required by law to track all those changes. Well, you are in Australia. I'm just using that as an example. So by protecting this branch, we stop people from being able to delete the branch, right? And we also stop people from overwriting that branch history so that you know that the changes on that branch, the changes have always been there since the time you started the protection. The little box here that says require pull request reviews before merging is basically the concept that when I make the changes to the code and I open my pull request, somebody else had to actually go through and approve it. They had to tick the little box that said approve and click on submit review. And then once that would happen, we would then allow the code to be merged into that master branch. Like I said a couple of minutes ago, you can also tick an option that essentially says, you know what, if I do approve this code, right, and then somebody else then pushes and makes changes to that code, I'm required to make that approval again before we let it go into the repository. This is a new feature that we brought in recently. It's been on github.com for a little while, but we've brought it now across into GitHub Enterprise. You can put a file called a code owners file into your repository, and in that file you can say, for all the files that are sitting in the docs folder, the documentation team have to do the approval on any changes to those files. But any files that are JavaScript files, then that might be the JavaScript team, or maybe a particular person is required to approve any changes to JavaScript files. So let's have a look at what that might look like. I'm going to go to blog, GitHub blog, having a mental moment there where I couldn't even remember the address of our own blog. So let's have a look at some new features that are available. And what I want to find in our list. Oh, wow, so we keep bringing in new features. This was only at the top of the list not very long ago. Let's look for code owners. So if you're ever interested in new features that we bring in for GitHub, always go to the GitHub blog, which is github.com/blog. That's how bad I am, I couldn't even remember that. So code owners is a feature that we brought in July into GitHub.com, but it's now sitting inside of GitHub Enterprise as well. And what you do is if you create a file, I'm just going to make that a little bigger. There we go, that's a little more readable. So if you create a file called code owners in the root directory of your repository, and you use the following format for the file, then what will happen is that we will actually pass this file, we'll have a look at it, and then when we're looking at pull requests, if pull requests happen to any of the files that fit the patterns that are matched here, we will automatically invite that particular team or that particular person to review the code, and it requires their approval before we'll let it merge into master. So you can see here, for example, in this file, any file that ends in .js, in other words, it's a JavaScript file, then either the user whose name is Octocat or the team, JavaScript team, the GitHub/JS team, are required to review any changes to that file before we're allowed to go into production. Any files that sit inside the documents, the docs directory, are required to be reviewed by a person who has the username docs@example.com. In this case, what it'll do is it'll send that email to that email address, and that could be a group email of your documentation team, or it could be a single person. But basically, they will be required to review and approve before any files that change inside the docs directory can be merged into your master branch. You'll notice that it says here the format may be familiar if you use Git attributes. Git attributes are a way that you can provide configurations for Git repositories, and we follow the same kinds of format that you use. So you can see here, for example, that the order is important. I probably didn't make this very clear. The order is important. So if we look at this particular file, by default, any file has to be approved by this particular person. Defunct. Defunct is actually the CEO of GitHub. So in this particular, if any kind of repository had this entry in its code owners file, if people wanted to make changes, the CEO of GitHub would actually have to approve it before it went into production. The order is important. So what happens is it's the last entry that matches the pattern that will win. So you can see here, then, in this particular case, a JavaScript file, that will override this requirement that defunct has to approve it, and instead it only needs to be approved by Octocat or the JS team. This would also override from that point there. So if I had a JS file sitting inside the docs directory, the only people that actually need to approve to the approval is this docs@example.com, whatever that user happens to be. And you can see once you put that file in place within your repository, code owners will automatically be requested to make that review whenever a pull request touches those files that they're designated as owning. Does that make sense? Cool. Any questions about that?
Is there a way to assign like default reviewers from settings?
Default reviewers from settings? No, not at the moment.
Because this way, like, let's say if someone edits this file in a branch,
Yep.
and they create a pull request.
Yep.
Let's say if I remove defunct, so
Yep.
they want to be assigned.
Yep. The other thing that will actually happen is, however, it has to go through the code review process. Code reviewers are meant to look at the code. They will see that there's been a change to this file. They should be rejecting it at that point in time. And then you go and slap that developer on the wrist for changing something they shouldn't have changed. Brilliant question though, really good question. But you got to remember that when you're protecting your master branch, those changes can't go into production until someone's approved them. And because you have code owners, they're being requested to review those changes. They will see the fact that this file has been changed, and there is a pile of stickers. And if this was not meant to happen, you just go and reject it. You say change is required, please revert this file back to the way it was. So it's actually built into the management process. The good thing about that is that if you want to change who actually is allowed to, if you want to change, if you want to change who can authorize or can approve code to be deployed, you can tell I'm getting tired. All right, you use the same process that you would use to change code, to just change this file. You open a branch, you change the file, submit it, and it gets approved then by the administrator, and it goes through. So again, you're tracking and you're keeping a record of who actually changes in terms of their approval process. So what we try and do here is make the auditing mechanism the same for no matter what's changing inside a repository. It makes it easier to track those changes. It makes it easier that if you ever have to be audited by an organization, that you can point and you can say, look, here is the process by which we use to change who is allowed to approve changes to code. Does that make sense? Okay, so that's the code owners. Now, there can be a hiccup with having code review. I mean, I went through a code review process here just because I wanted to fix a spelling mistake. But that can be a little bit annoying, right? Obviously, if you know that all you're doing is changing a spelling mistake on a web page because you've let me code your web page and I can't type, but you want to get it fixed quickly, you can actually choose to bypass in certain circumstances the requirement for a code review. Again, this is audited and it's recorded in the conversation around the code change. All right, but ticking this box here allows you to say, okay, the repository administrator can always choose at any point in time to bypass the code review process. The reason you might want to do that, like I said, is to fix a spelling mistake. It could be that the person that you've made responsible to review a particular piece of code is not available right now, and because it's just a spelling mistake, you don't have to wait 3 weeks for them to come back off holiday or 3 days for them to come off sick leave or whatever it is to approve these changes and get it out. So an administrator can selectively choose, okay, to fix this spelling mistake, we're not going to require a review, we'll just allow it to merge. So we dismiss that code review requirement. Again, we track who that is. We track the reason why it's done. They have to actually pop in a message saying this is why we did it. And then you can look at that in terms of your auditing information. So obviously, if you start seeing people pushing code in production and bypassing the code review process through the administrator, again, you can start going back and enforcing this. And I haven't clicked on something.
No, it's just a question.
Yes. Oh, yes. Hello, Facebook.
It's B, and B asks, for an internal project, I'm the owner of the project. How should I decide? I'm assuming she's talking about the repository.
Yep.
How should I decide when to use upstream fork repo process over having everyone work in the same repo branches?
How do you decide that?
Yeah.
How well do you trust your developers? That's not a technical question. What you're looking at are the people that you're working with at that particular point in time. So for example, has everyone heard of the Swift programming language? Alright. So that's Apple's replacement for Objective-C. Alright. So what they did a while ago, a couple of years ago, it wasn't that long ago, some time ago, they actually open source Swift. Alright. So there's actually a repository on GitHub.com for Swift, the Swift programming language. Here it is here. GitHub.com. There it is there. All right. So that's the repository for the Swift programming language. Okay. So you can see there's 177 pull requests in there at the moment. There are 6,258 people who have actually forked this project. Now what they did was, very early on, they only had to select people who were allowed to actually work directly in the repository. And those people that are invited to work in the repository, they're allowed to create a branch, go through, make changes to the branch and submit a pull request, and then it gets merged into the code. For everybody else, and these people originally were just Apple employees, for everybody else, they had to fork. They didn't have permission to work inside locally. They actually had to fork the code, all right, and that was what was required. They would fork, make their changes, and then submit their pull request from their fork. What happened was that Apple then built some very rigorous testing mechanisms, so continuous integration builds and things like that, to test to make sure that the code that's been written, that's been submitted from the fork side of things, was robust and, obviously, and should be included in the project. And that worked really well for them. So what they then decided to do after that is they said, well, we've been collecting all this data about who's actually been opening these pull requests. And we know who are the good members of our community, and by that I mean the people that they submit a pull request and maybe there's one change requested or two changes requested, or maybe it just goes through without any changes requested at all. In other words, they're good, strong developers apart from some minor tweaks. They could then go and actually, their fork would then be actually merged into the original repository. So what they then did is they started inviting those people to actually be part of this particular repository. So instead of them having to fork, they become then trusted members of the development team, and then they started doing things like being the community leaders, and then they started looking at the pull requests that were coming through from the forks and approving or disapproving of those things accordingly. So I don't think this answers the question directly, but what it basically comes down to is to how well do you trust your developers? Do you want to have them working in your original repository? Do you want to give them permission to be there? Or do you want to have them sit off somewhere else and do the fork and keep them a little bit quarantined? That choice is up to you. What you need to do is put in place a process by which you can vet those people and decide when you bring them from this side of the fence into the inside of the fence. Does that help? There's no technical reason, it's purely how do you trust your developers in that space. And lots of people do it in different ways. Cool. Can someone remind me what we were talking about before that question?
It's in the other tab, protected project.
Thank you. Awesome. That's right, we were talking about the spelling mistake because I can't type. All right. So the problem is that administrators may not want to be the ones responsible for dismissing code, dismiss pull request reviews when they're required. So you can actively delegate that responsibility to other people within the organization. Now, repository administrators can always choose to dismiss a pull request review, but if they don't want to be the people having to do that, again, they can pick a trusted lieutenant, right? Again, you notice everything that we talk about in GitHub is about trust and how you trust your developers and how you work with your developers. Now, at this point in time, Daniel can selectively choose that when the timing is right and the reason is right, to bypass that requirement for a code review. Again, you would only do this for things like fixing a spelling mistake, where you put it up and you quickly want to change it before it looks embarrassing to the audience. You would not want to obviously bypass the review process when you're bringing a new feature to the product, or you're fixing a bug, or something along those lines. Now, the thing about that is, like I've said before, for every one of these buttons that you tick, the more you tick, the more protected your code is, the more the tick, the slower your process can be. And it's just a matter of finding that right balance that you need to do. So if we look before at github.com/github/github, so let's look at the source code to GitHub. I'm not an administrator, otherwise I could show you what the actual things are around the protected branches. I keep forgetting about that one. All right. I've mentioned continuous integration a couple of times. Does everybody know what that knows what that means? Put your hand up if you don't know what it means. It's all right. It's not embarrassing. I didn't know what it was until I joined GitHub. Thank you. Continuous integration allows you to do things like run tests automatically every time somebody makes a change to code. All right. So we spoke earlier about in the process of the GitHub flow, you would open your branch to have an experiment. You would open your pull request to start the discussion with your community, your fellow developers, your manager. All right, and they would have a code review process to make sure that your code has been looked at by somebody and they say, yes, I agree with this. But you also want to make sure that the code actually meets your behavioral requirements, right? So you write things called unit tests for that code. These unit tests will go in and they will say, this is the expected response if I run the following function with the following parameters. And they will go through and do that. If any of those tests fail, in other words, you're not getting the behavior you expected from your application, you don't want to merge that code into your master branch and hence put it into production. So continuous integration can be set up so that every time you make a change to a branch, to code in a branch, that continuous integration tool, which is a build environment, you might have heard of products like TeamCity, Jenkins, Travis CI, Circle CI, Build Kite. There's a whole bunch of tools out there that what they do is they can be notified whenever somebody makes a change to the code. They can come into the repository, clone the repository, run the build process. For example, if it's a Java repository, compile it into Java code. It might be that if it's a .NET application, then obviously, compile it the .NET code. Obviously, not all code needs building, so JavaScript doesn't require compiling. But what it can also do is run those tests. And if those tests fail, they then let GitHub know that the test fails. Alright, that's where this button comes into play here, requires status checks to pass before merging. What happens when I tick this box, and unfortunately I don't have any available to actually show you, but what will happen is here, if I tick this box, any of the continuous integration tools that I've set up, they will actually provide, like I said, what's called a status check back into GitHub. And it'll be listed here. So I might have, for example, an event that happens when I change the code in the repository, and we will go through the code and make sure the unit tests run. We could also have another continuous integration that runs that if I'm writing documentation, it'll go through all the documentation and any web links that are in there, it'll check to see whether or not they are live links. And if they're all live links, they'll report back using a status check that it's passed those particular tests. If those tests fail, it'll bring back a status check of failure. So basically by ticking the box to say require status checks to pass before merging, if any of those automated testing processes fail and they tell GitHub that they've failed, you can't merge the code back into the master branch. Right? Now running tests is really boring. Again on github.com, sorry for the source code for GitHub, I'm going to look at a pull request that we have. I'm just going to pick one. You can see here that we've got, against the pull request, we've got some little colored marks. So this one here is an orange one. This is an orange one to say that we ran 20 different builds over the source code that were involved in this pull request to make sure everything was okay. 18 of them passed, 2 of them failed. This one here, but in this case here, the ones that failed were not required to be passed to actually merge the code. This one here, 18 passed, but the ones that failed were mandatory to actually pass. So let's go and have a look at that one there. See, we have two failing and 18 successful checks. And what's happened is, just scrolling down a little bit better, we run, every time we make a change to the source code in our pull request branch, we go and run 20 tests on it. Some of these things include things like packaging GitHub and creating a virtual image so that we can deploy it in AWS, so our customers can deploy it in Hyper-V or whatever it is that they want to deploy it in. We make sure that we can actually go and build that virtual image, and we go test that virtual image to make sure that the application launches and things like that. Just a general build to make sure that we do actually have some compile code that's part of GitHub, just to make sure it actually does compile. We run benchmark tests so that we look at functions, and if we've changed those functions, we test to see whether or not those changes that we made have actually impacted upon the performance of GitHub. And if they have, we will actually fail the test, and so we can't actually deploy that code out into production. Building a Docker image, because we're investigating how we can actually deploy GitHub in Docker at the moment, though we haven't actually got a solution there right now. We've got some tools that look at the JavaScript components of GitHub and make sure that those things are okay. We actually have a continuous build process that goes and links our code to make sure that our developers are adhering to our coding requirements. For example, we may require that they name variables with the capital letter M, for example, for some strange reason. We can build tests that will go through and make sure our coders are doing and writing the code the way we ask them to code. And if they don't do that and the tests fail, we will actually stop the code from merging into master and going into production. All right, and so these are all called status checks. All right. I keep looking at that screen, and because it's behind, I keep getting confused over the process. All right. Now these two here, we're obviously looking at some work around Rails 4, and at the moment GitHub if we actually sit it on top of the Rails 4 library instead of the library we're using at the moment, actually fails to run. So obviously we need to go fix that before we can actually implement Rails 4 within our particular projects. So, you know, essentially status checks allow you to do all kinds of things with your code and to test your code. And if any of those things fail, you can stop code from being merged into your master branch. Does anyone have any questions about that?
How do you actually link the testing together with GitHub?
That's a good question. I can't show you for that particular one because I'm not an administrator, but I'm going to find another repository that I've got here that we can have a look at. Just bear with me 1 second. All right. So this here, I've used this to demonstrate integrating GitHub with AWS Lambda. Does everyone know what AWS Lambda is? Yes? Put your hands up if you do. I don't want to embarrass people who don't this time around. Do you know what AWS Lambda? Okay. That's awesome. AWS Lambda, because it fills up 5 minutes of entertainment time. AWS Lambda is a service that Amazon provides that allows you to write functions, and to be able to deploy those functions, you don't need to build a server environment. You don't have to build an image and install Linux on that image, install a whole bunch of packages. They basically provide this is known as serverless computing. You may have heard of this. What they do is they provide you the ability to just deploy a function, and it sits inside their wonderful farms of computers and processors and stuff like that, and they just provide an environment for that function to run under. For example, you can execute Node applications. You don't have to build the Linux box, you don't have to install Node, you don't have to do anything like that at all. You just say, this is a Node function, here are all the Node libraries I require, hand that to Lambda, and Lambda just goes and automatically does all that for you. Now we can see here, if I look at the settings, and I'm looking at what's called the hooks and services. And there's a couple of things that I've got here. You can firstly see that there is what's called a webhook. A webhook allows us to notify an external service when something happens inside of GitHub. So in the case of I open a pull request on a branch, and somebody makes a change to that branch, we track that event. And we then go send a message to a continuous build tool that can then log in, clone the repository, run the tests, and then use the APIs, the GitHub APIs, to then report back into GitHub. Does that make sense? Awesome. The difference between that and the service is that we've also built some pre-built integrations. So this here just allows you to send a generic event, right, to an external application. The application can come in and do whatever it decides to do. However, there are some tools out there that we already know how we want to communicate with them and what kind of information we want to send with them and what we expect to come back from there. And so we've built some plugins, right, that are called services. So for example here, this is a plugin that allows us to communicate with Jenkins, and then Jenkins will come in and do its job. And I can add services to integrate with things like, you can see here, AWS Code Deploy, OpsWorks. There are a whole bunch of tools that are out there, and they're used for all kinds of things. It might be Bamboo is a continuous build environment from Atlassian, for example. There is Bugzilla, which is a bug reporting environment. Anybody that works in the Mozilla projects know about. What else is there? Code Review Hub is like, for example, like I said, we have code review that's built into GitHub, but if you need something a little bit more complex or does something in a slightly different way to the way we do it, then you can go and integrate with external code review tools. So again, whenever something changes in GitHub, this external code review tool can be notified. It can go and notify the reviewers to do their work. They come in, approve or disapprove, and then it'll notify GitHub again. So these are all the services we provide, which are basically integrations for, look, I'm just down to D, and it still goes on and on and on and so forth, right? To HipChat. HipChat is like Slack, right? Again, that comes from our friends at Atlassian. And DevOps services. So for example, if you've deployed a GitHub inside of IBM Bluemix, then we can actually integrate so that when changes happen to GitHub, we can actually go and advise the Bluemix DevOps services, and they can come in and automatically deploy software, for example, out of the repository. and so on. So that's how you integrate with these third-party tools, so they can come in, clone the repository, run their tests, whatever it happens to be from there. So if you've got your hand up like you're about to ask a question, sorry.
No, I can ask it. No.
Sorry?
I can ask.
Ask a question if you like, yeah.
You said something about Slack. Is it also integrated? Like,
Are there integrations with Slack? Yes, absolutely.
so I can get some message, like
Yep.
something pops up?
So there is a basic integration with Slack that's available, so that whenever you make a change in a repository, it'll drop a message into the Slack channel saying, hey, Daniel has just made a change to this repository. They may have pushed a commit, they may have opened an issue, they may have closed an issue. So if I go into Slack, for example, we use Slack here.
So basically, we are not required to use emails.
Yeah, you don't need to use, like, you still receive emails as notifications if that's the way you want to do it, but you can switch all of that off as well. But if I go into, oh boy, I hope I don't expose anything here, but if I go into the solutions engineering channel, all right, you can see I'm getting notifications that in the solutions engineering repository, Hubot, our automated bot service, has opened an issue in there, right? And that issue happens to be radar weekly planning. So in other words, that's an issue that solutions engineers, people in my team, we use that to report to everybody else what we're working on this week. So I'm being notified directly in Slack that this has happened and who's actually opened that issue, and then I can go in and look at it and interact with it from there on in. You can see also that just after Hubot opened this week's, he closed last week's. Also being notified that a user called Michael Twofish just merged a branch back into our master branch, and that was issues around the 2.2 support guide. When Michael also pushed a commit into a particular branch. So you can actually set those integrations up so a lot of notifications come through to Slack from there. We could get even scarier. Maybe the next time I can come up and I can tell you how to actually manage deployments directly from Slack. All right, so you can actually say, where can I deploy? All right, and what will happen is that we will come back to you and say, here are all the environments, the test environments that you can deploy in. Okay, go and deploy in test 5. It'll go off and do it, and then give you all the information you need to then go and monitor that test. We run our whole company out of Slack. Cool. All right. So let's go back. I think we were talking about protected branches still, were we not? I need to go back to an earlier set of code. There's our settings, protected branches. All right, there's one more button that you need that I've checked here, and that is require branches to be up to date before merging. Does anyone want to have a guess as to what that might mean? He says, looking at his watch to see if he's stalled for enough time. No?
You need to merge master into your branch before you can merge that.
Spot on. So for that, I'm going to give you a t-shirt. So, Joel, can you give that to the guy? So if you go to there's a web address there, go to the store, pick a t-shirt, your design, your size. We'll ship it to you, no matter where you are in the world, for free.
Thank you.
Awesome. Surprise presents, they're good, aren't they? Yeah, you're absolutely right. So obviously if you're making changes in your branch and then someone goes ahead and then they've done their branch, they've done their pull request, it's submitted, it's merged, it's gone back into the master branch, all of a sudden your code is not in sync with the master branch. There are two things that can happen at that point in time, depending on what's actually happened. If somebody actually hasn't changed their code, hasn't changed any code that you've changed as well, that can be okay. In some cases, people just merge their branch, and that's all right because everything moves on and stuff moves on from there. In some cases, you may require that the master branch is merged back into your branch before you run your tests and things like that and merge it back in. So by ticking this box here, you can make sure that if I've made changes to my branch, in the meantime, you've come in, done your bit, changed the master branch, this makes sure that my branch has at least been made up to date with how the master branch looks at right now, apart from my changes, before we push that back into the master branch. This makes sure that any continuous build and continuous integration testing that you're running is running with absolutely the latest version of every piece of code change that's happened. Okay, cool. And I've been pushed at my time, so we're kind of done for the night. I've shown you a whole bunch of stuff. I just want to say thank you so much, those of you who use GitHub. We really appreciate it. You know, everything that you do, whether you're contributing to open source software, I'm getting teary, that's how tired I am. It's fantastic, please keep it up. Those of you who don't use GitHub, please come and have a look at it. Get involved in open source projects, you know. Contribute software to the world, because we're the people changing the world right now, as in us developers. All right, so thank you very much.